All right, good morning. So, good morning. Any questions? Homework 6 questions, etc. So I got lots of Git repos from people already, which is awesome. Do we still need to include comments with name, dates, class description, and main.c? At the very least, put your name into each of your files in the comments. That's just, general good practice. But mainly I want the description and all of that inside the README. But yeah, I'd say always put your name at least into your source code files. When waiting for the user to hit enter, is it fine to ignore everything else they might type before hitting enter? Yes, that's totally fine. If they lean on the keyboard and then hit enter, that's okay. Is it alright to use switch statements? Sure. I'm a fan of switch statements. Is it okay if we use fgetC standard IO in a loop to clear out the extra input before asking the user to re-enter their answer? I think that will work. The easier way to do it is to just use fgets and make sure that what they type was exactly an H, a C, or an L followed by a new line. So you can use string compare. So yeah, that would work. If you're worried about excess memory allocation, so I mean, I'm not going to go super extreme on testing your code. I could, type in 1,000,000 characters instead of just the letter H, and your fgets would kind of freak out a little bit about that because fgets will only read a certain number of characters at a time. I'm not going to test it with that, right? I'm going to basically test it with an H, and I'm going to test it with some stuff that, is H followed by things, and with something that's not an H, stuff like that. So yeah, you don't have to get super fancy with that. But if you did an fgets with a buffer that could only hold 10 characters, and I typed in 25 characters, fgets will read those first 10 or 9, and then complain. It'll read the next 9, complain. It'll read the next 7 and complain, and then it'll wait for you to type something again. That's okay. Let's see. Question on casting and the predict statement. Yeah. So there was a bit of questioning about this yesterday, and I'm not intending for this to be particularly complex. The prediction is basically 1 plus the log of 1 plus high minus low. To calculate the log using the log function from the math library, these need to be doubles, or maybe floats or longs, but you can do them as doubles. So you need to either cast those or store them in doubles temporarily. The result of the log operation will not be an integer. You can add 1 to that, that's fine, and if you just save that in an integer variable, it will get converted to an int. So we can do something like this. Let me make some. do negative. All right, so I've got a floating point number here, a double precision floating called x. I've got an integer named I. I'm going to say I equals x, and then just print out the value of I and see what it gives me. So I'll compile that, and it gives me 3, which is what I wanted. The business of casting, we don't really need to worry about it, but you encounter it a lot, especially when looking at like system level code. Casting is basically saying this thing over here on the left is an integer, this thing over here on the right is not an integer, it's a double. Okay, what we can do is we can put the word int in parentheses and say, hey, take the value of that double precision number, change it to an integer. Okay, it's not going to change the behavior of this program, but it's sort of letting us know that we understand this is not an int we're assigning to an int. This is a double, right? And somebody looking at this code, you know, has in the code, you know, recognition of the fact that we're converting from one type to another, and in particular, we're converting from something that has more precision to something that has less precision, so there's potential precision loss. Now, if we try to do this in Java and we don't have that cast in there, we'll get errors, or in other languages. So it's just kind of, you know, helping the compiler along here. Really makes no difference in C for what we're doing, so you don't need to do that. You can calculate your prediction as a double and then just assign it to your integer value and return that. That should work fine. But I added that thing about casting it here just to recognize the fact that we are converting from a double to an int. Don't return a double because it'll say I'm going to guess your answer in 6.23 guesses, and that's not what we want. But you definitely do not want to round it. Don't add 0.5 before you convert, because that'll get you the wrong number. All right, other questions? Log 2 will treat the number in parentheses as a double already. So the default behavior of the log function is to ingest a double and return a double. And if you want to use a single precision, you can use log f and so on. And again, when you use the log function, whatever file you're using it in, you have to include math.h, and when you build your executable, you have to do -lm on the GCC line. Is it okay to have extra files for other functions? Absolutely, and it's strongly encouraged to have extra files to break this thing up more nicely. Let's see, long question in chat. I had trouble with math.hlm when I got stuck. GCCO main, blah, blah, blah. LD predict.o, predict undefined reference to log 2. So I don't think log 2 is a thing. Found the LMS to go at the end of predict of the main executable. -lm or -lm. Why is lm can't be at the beginning? Like so, GCC-lm. So when you want to use the log function, let me put math.h in first. Alright, so if you compile normally, it will tell you undefined reference to log. And again, when you get these messages that talk about .text, or you see this collect to, or you see the word LD, that's not a compile error in the sense of your C code. That's an error in the sense of linking things together. And it's usually when it says undefined reference, you misspelled something, you forgot to include a file, something like that. So in this case, the undefined reference is to log. Well, we haven't written the code for log anywhere. We included math.h, but math.h does not have the code for the log function. It has the prototype for it. Okay, but we can look at this file. And this is always a risky proposition to look at these files. Oh, it's actually defined somewhere else. Anyway, this will prototype the function for us, but it doesn't actually have the actual code that's used to calculate a logarithm. So that's sitting in a runtime library. And when we compile our code, we need to specify that, and so we say -lm, which includes that. So somebody asked in chat, why can't we put the -lm in the beginning? I don't know what the official answer is for that, except that the -lm is not being used by the compilation phase, it's being used by the linking phase. And I suspect that might be related to why it has to go at the end of the statement. But I don't know. I've never tried putting the -lm anywhere except at the end. There may be some good reason why it can't go in the beginning. But I would say just put it at the end. Not in there. But anyway, there's an environment variable that's set up that tells where the libraries are included from by default, and the -l says include the library named m, and that's looking for a file called libm, usually libm.a, and it's a collection of compiled but not linked functions, in this case for square root and sine and log and things like that. And we can pull from those selectively when we're building our executable. By using GCC. And like I said yesterday, linkers are kind of a whole nother dimension of weirdness in the compilation process, because it's really taking all of the different parts and pieces and trying to link them together, right? So that when you make a call to a log, it knows where to find that code and how to execute it and so on. What do you want to see in our GitLab repo? It's in the assignment. Is it fine to have the .o and executable files there? Absolutely not. So, so go back to the assignment. Git requirements: readme, makefile, .c and .h files, nothing else. Okay, so it should be just those pieces. So you can git add star.c as long as all of the .c files in your directory go along with your project. But I strongly recommend not using wildcards here. I strongly recommend adding your files by name. And, you know, to avoid having to type those in, make yourself a script or an alias, but make a script that says, you know, git add this and this and this and this and this. And then git commit with a commit message that maybe comes from the command line argument. And then you can put your git push origin master right in that script also. And now anytime you make a change, you can just run your script. Maybe it's called update or something. You can say update space with a commit message, and it'll go ahead and do all the git stuff to push that in. So if you have subdirectories and you do a wildcard, yeah, those subdirectories will get added in also. And, you know, honestly, when I'm working on projects on my own, yeah, I just do star. Unless I have really large files that I deliberately don't want taking up space in my repo. But for this one, let's go ahead and be really clean with the Git repository. And just push in the relevant source files, the make file, and the readme. Yeah, so that alias you have looks like it would be good. I'm looking at the chat messages right now. All right, cool. Other questions? All right, well, let's keep going with Git. Let's talk about managing multiple Git repositories. So this is something that's come up, and I think we started to talk about this yesterday. But the basic setup here is, you know, you might have your laptop, and you've got a Git repository, and you're working on your project, and maybe you periodically push this up to GitLab. And you make some more changes and you push those up. And so you've got your main project sitting here on your laptop, you've got a copy of it over here, and eventually, you know, I'm going to download that if it's a project for class, and make a copy of your repo in my own account, and then test your code from there. But what you might find is that, you know, you're working on your laptop, you're pushing stuff over there, but maybe you have another machine that you want to also work on. And it might be the Linux server. And you have your account on here, and you want to work on your project on the Linux server because that's where it's going to get tested, right? So what you can do is you can come over here and you can use a git clone command and take this repository and make an exact copy of it over here on the Linux machine. And once you do that and you have your files, you can go ahead and make changes to those files. And when you're done, you can do a git push. Now the idea is the copy up here on GitLab should always be the latest version of your repository. So I've made some changes here. I've pushed them up to GitLab. Let's say I go back to my laptop and I want to do some more work. I don't want to just start editing these files that I have sitting in my laptop because I don't have the changes that I made over here. So the first thing I'm going to want to do is a git pull, which will take the current copy of the repository on here and update my local copy to look exactly like that. Now, this copy of the code is exactly the same as that. I can make additional changes, I can push those up. I can make more changes and push those. I can make still more changes and push those. And now the latest copy is here, and it's also here. Now if I go back to the Linux server and I want to start doing some edits, first thing I have to do is a git pull. Right? Make myself a updated copy of these files, so that now this is in sync with that, and then I can make some changes and I can push that and so on. And if I have a third machine, this is my beachfront machine, right? I can come here, and the first time I want to do this, I'll do a git clone, and then from that point on, anytime I make changes, I'll push. Anytime I want to start editing, I'll pull. And you can have multiple machines all staying in sync with each other, right? Provided anytime that you make changes, you push them up to GitLab, and anytime you're about to start editing, you pull down the latest version of the repository. And so this might be a setup you would have if you had multiple developers working on a project. They could each be working with their own repository, but when they make changes, they push those up to this shared location. And then if somebody else wants to make further changes, first thing they do is they pull down the latest version, and then they go ahead and they make changes and push it back up. All right, so this works great in theory. Let's go ahead and play with this. All right, so let me start with a completely clean directory. So I'll make a directory called class, and I'll assume that this is the directory I'm using on my laptop to do all of my work. So I'll make a README. I'll make a main file. Alright, so I got some files in here. So one time do a git init. Okay, that makes your repository on your local system. You only do that once. Okay, if you do it again, it'll say it's reinitializing the existing repository. No need to do it more than once. Okay, now I have these files I want to put under git control, so I'm going to say git add star.c and readme. And then if you do a git status, you've got 3 files staged but not committed yet. So let's commit those. So here's my first check-in. This is from the laptop. Okay, my Git repository is totally up to date at this point. I want to push this to GitLab. So again, one time per repository, you do the git add command. Okay, so git remote add origin git at gitlab.com colon username on GitLab slash and I'll just call this sync demo .git. Alright, so that's a one-time command. So from this point forward, anytime I make changes, I'll do git add, git commit, git push. Okay, I've done the add and the commit, git push, origin master. This took like 10 minutes this morning. We'll see if it's still laggy right now. Looks like it's going to be laggy. But this will create my repository over on GitLab. Okay. And that's what we've been doing so far. So let me let this run in the background. And let me show you what we're going to do with this. We're going to come onto another machine, which for us is going to be, you know, the Linux server. I'm going to go into a directory underneath which I want my new repository to be. Okay, so each repository is in its own directory. So I'm going to go into the parent directory where I want that new directory to be. And I'm going to do the following command. Git clone git at gitlab.com colon username, whatever your username is at git, slash the repo name.git. And that's going to create a subdirectory. Hold on, I can close my window. It's very slightly quieter. Okay, this is going to create a subdirectory named repo, whatever the repo name is, under my current directory, and it will be a clone of that repository from GitLab. Alright, we're still waiting for the push to happen. I don't know why this is. This started happening yesterday during class. I have no idea, because usually this thing is like immediate, but something is lagging somewhere. I really need to reboot my laptop at some point. Alright, so I'm going to say git clone, and that's going to do this business of, you know, making an exact copy. And then I'm just going to make changes, git add, git commit, git push. And then when I come over here, I'm going to say git pull, make some changes, git add, git commit, git push. Let me show you what can go wrong with this. Okay, so here's one machine. Here's another machine. Here's the GitLab repo. Alright, so I'm going to make changes to a file. I'm going to say that I'm, you know, doing file A version 1. and I'm going to push that up to GitLab. And then maybe I'll make some more changes, and this will change to file A version 2. And I'll push that up to GitLab, and now GitLab has file A version 2. Now I come to machine 3 and machine 2 and I want to start doing some work. I'm going to do a git pull. And this is going to have file A version 2. Everything is in sync. Okay? And let's say I make some edits and I get version 3 and I push that up to GitLab. So now this is version 3. Alright, if I come over here and I want to make some more changes, first thing I'm going to do is a git pull. I'm asking Git to change this file from version 2 to version 3. Well, it knows how to do that, because that's what happened when I pushed version 3 up here. It changed from version 2 to version 3. So this will change to version 3. That's all fine. And maybe I make some changes. Here's version 4. Push that back up. Come back over here, start doing some edits. This is version 4. Okay, so far so good. This is how it's supposed to work. Now let's say I make some changes over here. I'm on version 5. I push that up to GitLab. That's version 5. Now I come back to machine 1 and I don't do my pull. I just immediately start changing version 4 and I come up with version 6. And I say, let's go ahead and push that. Well, Git's going to complain. Because what's happening is I'm trying to push a new version of this file, version 6, but it's not a modification of version 5, which is what GitLab has right now. It's a modification of version 4. And whatever this person did in version 5 is probably not inside version 4. So I'm trying to go from an old version to a very new version, skipping this intermediate version. And Git's going to throw its arms up in the air and say, I don't know how to do that safely. Right? Because the danger is that, you know, there's some really good code in here in version 5. It was not in version 4, and so it's not in version 6. And if version 6 gets pushed up here, those changes from version 5 are potentially lost. Okay, and Git's going to work really hard to try to keep you from losing important information. And it will opt to say, I don't know how to do this, rather than just blindly do it and potentially overwrite changes that were already saved. So why did this happen? It happened because before I started editing, I did not do a pull. Now, if I had done a pull, I would have gotten version 5, change it to version 6. GitLab would be fine with doing that update. So you always want to pull before you push if you're working on multiple machines, right? Now, if this happens to you, what do? Well, figure out what the right version is, and maybe just remake your repository, right? You can always go up here, you can just start a new repository, delete the old one, start a new one, add me as a reporter, go back to the beginning. That's guaranteed to work, okay? Less extreme versions would be to, you know, save this new version of your file, pull down version 5, edit that with your changes, and then push that back up, okay? Best solution of all, don't let this happen. Always push and pull in sync. That doesn't always work out, right? Sometimes we forget to pull down. And this happens with, you know, group projects. And it's harder there because, you know, the changes for version 5 were made by one person. This is a person on a different continent, right? How do you reconcile these? So these can be challenges. All right, but for us, since we're the only person working on this and we've got complete control of all the versions, it's usually not a big deal. But it will complain. How are we doing? Hey, we managed to do our push. All right, so we pushed this file called sync demo. Let me go to my list of projects on GitLab. I'm going to do this on a side window because it's got everybody's homework 6s. So I will do just projects owned by me. And so there's my sync demo. And I can go in there and there's my readme and there's my main function and so on and so forth. All right, so I could make more changes and push those over. I was hoping the second time would be fast. Alright, so this is definitely something pathological because it's not just a new repository. I'll have to figure that out another time. Alright, so once that's done, we'll pull it down. Alright, so here's the other thing where you can get in trouble, which is if you remove a file from here, right? And then I try to do something with Git, and Git has a file sitting in there, and the file is missing from here. It's not going to know how to reconcile those differences, right? So if you remove a file that's under Git control, you want to do git rm, which will also do an rm, but it also tells Git, hey, this file is being removed. So when the file doesn't show up the next time you talk to Git, it doesn't get confused about where is this file. And if you want to rename a file, git mv instead of just mv. Let's see, so question, how would you have a lot of people working simultaneously on a Git project if there are a lot of people trying to push constantly? Good question. Really, the way that you're supposed to be using Git for development is to start working with what are called branches. And so branches are, you know, these parallel universes. You can have a new branch of your project, and it basically becomes an exact copy. But on that copy, you can make changes, you can push, you can pull, you can do all of these things. And somebody on a different branch doesn't see any of that. Okay? So you're doing all of your own development, and if you're working on, you know, one particular set of features, you make a new branch for those features, you can treat that as your own private repository, right? And the stuff that you're doing is isolated from everybody else's work. So somebody else is on another branch, they're pushing and pulling and committing and adding and so on and so forth. And then at some point, those branches get merged together. So I've been working on a new feature branch. Once that feature is finished and validated and checked off and ready to go, we merge that back into the main branch. And as long as nobody else has been working with, you know, things that were affected by that set of changes, right, it'll merge in seamlessly. And now we're back to just one main development branch. But it does take coordination, right? You cannot have a project under Git control with multiple developers and just say, you know, work on whatever you want, whenever you want, because inevitably this kind of thing will happen, right? I mean, imagine that both people were making changes to version A4. There's no way that that can be automatically reconciled, right? So ultimately, at some point, you do need some you know, external control over who's working on what. So that gets into the whole kind of project management, software development discussion, and that's always a separate issue. How's Git doing? All right, Git is pushed. Good. So let's switch machines here. So I've got my repository. And now I'm going to a new machine, so I'm going to go to the Linux server. And let's make a directory, you know, for my project. And let's say under here I want to work on this sync demo. Okay, so I'm going to do this one-time command. Git clone git at gitlab.com : username / syncdemo.git. And this will create a subdirectory under my current directory with the name of the repository. And if I go in there, there's all my files. And it's got, you know, the latest version of my README. and I can look at my Git history and see the check-ins that I've done, and so on and so forth. Alright, so I'm over here. This is where I'm working now, is on the Linux machine, and I want to make some more changes. So let's make a better version of main.c. Cows should not make typos. Alright, so there's my comment block in the beginning, and I'll put a return statement in there. Okay, so I'm done for the day. I've done my coding on main.c. What do I want to do? Push it back into GitLab. So git add main.c, git commit, added some comments, and then git push origin master. Alright, that's it. It's synchronized up at GitLab. So now I come back to my Linux, my home Linux machine, my laptop, right, which still has this old version of main.c, and I want to start doing some work with this. So first thing I'm going to do is git pull origin master. And that's going to pull down from GitLab and merge that in with my current repository. Oh, that's going to be laggy too. What the heck is going on? I got a big load average. It's not that big though. I don't know what's going on. Alright, so we'll let that run. But when this finishes, right, I will have a new copy of my repository files that are in sync with GitLab, and in particular my README will be, or my main program will be the one that has new comments added to it. So we'll let that percolate for a minute. Alright, so that's the basic idea of using Git to keep things in sync across multiple machines. It works well as long as you remember to keep things in sync, right? To push your changes over and to pull down before you start editing if you've made changes on from another machine. So the other way to do all of this is use the tar command or some other archive tool, right? And if you're just trying to work on multiple machines, I think GitLab is a really convenient way to do it once you have things set up. But for a quick and dirty one-off, right, you can just copy files, right? And so copying files is fine, but if you have a lot of files and if you have a directory structure associated with those, and if you're interested in preserving things like file information, creation time, access time, permission bits, ownership, and things like that, we can use a utility called tar. So tar is tape archive. So it's a utility that was originally written for manipulating magnetic tapes, for storing files onto mag tape and pulling them back. And you can read the manual pages for tar, which is the tape version of R. You can read manual pages for R. But there's 3 commands for tar that will be most useful for what we're going to do. And so I'm just going to show you 3 tar commands. And the syntax for these is very specific, and the way you use these is very specific, and if you misuse these, you can lose work. Okay? So the 3 commands are going to be tar cvf archive name and then a list of files. Okay, and tar is an unusual command. There's no hyphen in front of these switches. Okay, so tar cvf creates a file. Tar tvf archive name. This lists the contents of an archive. And tar xvf archive name. This extracts. So this creates an archive. This shows you the contents of an archive. This extracts files from an archive. Let's see how we're doing here. Okay, good. So on my local machine, there's my new main function. All right, so I've got some files in here. Let's go ahead and play with tar. But let me do this in a different directory, because this is a Git repository, and tar works with Git repositories, but I don't want to complicate things, so so let's just go into a new directory with these 3 files. Okay, so here's how I make an archive file. I'm going to say tar, this is create. The V means be verbose, give me more information. The F means my archive name is whatever comes right after this. So this is basically tar create, tar table of contents, that's the T, tar extract, that's the X. So let's make an archive. So I'm going to say tar cvf save.tar, and I'm going to list my files. So I'm just going to say star, okay, to put everything in here. But I wanted to do a C, not an X. CVF save.tar. Okay, so it shows me the files that are being processed, and it has created a new file called save.tar. It's about 10K, and it contains all 3 of these files. Now, if I want to look at the table of contents in that file, tar tvf save.tar, and it shows me what's in there. So there's 3 files, there's the sizes, there's the dates and times that they were created, the owner and the group, the permission bits. So let's say I'm in a totally new directory, there's no files in here, and I want to unzip my tar file, right, untar it, so I can say tar xvf and put in the name of the tar file. It shows me the 3 files that are being processed, and now I've got a copy of my files in this directory. Right? And even though it's 11:44 right now, the timestamps on these files correspond to the timestamps when these files were created. Now, ownership information will change depending on how you set system flags. I'll be the owner of this because I'm the one untarring it, but the other file information is preserved inside this archive, and that can be useful. All right, and if I go into a subdirectory, I don't know. I don't have directories there. I need a directory with some subdirectories. All right, so let's just say I go in here. Let's make a tar file. So I'll call it 215.tar, and I want to put everything in this archive. I'm just going to say period for my file list, right? So tar cvf, archive name, list of files. Period means my current directory. Okay, and tar will recurse automatically into subdirectories. So I could do an asterisk also. I'm going to do a period, and you can see it's creating subdirectories for each subdirectory in here, and then all of the files in those subdirectories. So now I've got this file called 215.tar. Right, these are all the things that are saved in there. And if I make a new directory, let's call it 215 copy. And let's put my tar file in here. I'll do tar xvf 215.tar. And bingo, I've got my whole directory structure back. Right? With 3 directories and a file, and all of those directories have all the necessary subdirectories and so on and so forth. So tar is a useful way to take a bunch of files and bundle them together into a single file. And whether you're pushing that file onto a flash drive or you're FTPing it over to another machine or whatever it is that you want to do, right? It's an easy way to drag around an entire directory structure with all of the information about the files in place and so on and so forth. We can also do things like compress these. So my tar file is 317K right now. If I say gzip 215.tar, it'll create a compressed version of it that's only 269K. Well, most of the stuff in here are things that have binary information in them. If you have a lot of text files or a lot of files with numbers in them or things like that, those will compress nicely. Okay, we'll talk about gzip another day. That's something that we can do is take a tar file and zip it, and so we get a file .tar.gz, and a lot of times we rename these to file.tgz, and that's colloquially called a tarball. And so it used to be when you were downloading projects from a website, typically you'd see tarballs and they'd be .tgz files. And they're collections of, they're basically directory structures that have been turned into tars and then gzipped. And so you unzip them and you untar them and you can reproduce the original directory structure. And what do you find in there? Usually you find readmes and source files and a make file and maybe a config file. And so you set everything up and you say make and it'll build your executable program. All right, the one thing to be warned about, and this is mentioned and tagged in the previous lecture, so go back and look at that because we're not going to have time to do a demo of this. But when you do the CVF command, right? If I want to put all my C files into an archive called save.tar, I could say tar cvf save.tar star.c. Okay, this is good. This is bad. Don't ever do this. If you do this, you're going to corrupt one of your C files. Let's say you have files called a.c and main.c and fun.c. All right. If I type this command, remember, asterisks are expanded by the shell. The shell looks at this as a wildcard and it says, let's find all the files that look like anything.c, and it's going to turn this into the following command. And it's going to execute this command. Well, what is this command saying? It's saying, I want to make a tape archive. I want my archive to be called a.c, and I want to put these files into it. And all the C code that you had in this file is gone. And a.c is now an archive file containing function.c and main.c. A.c's code, totally gone. Nowhere to be found. Right? And so you can lose your work permanently by simply forgetting to type the archive name in here. Okay? Linux is this way. It will do exactly what you tell it to. It won't spend a lot of time or energy trying to say, hey, that file already exists. Are you sure you want to do that? Okay? So by default, it will do exactly what you tell it to do. What do you do if this happens? You go to GitLab, you pull down your previous version of what you checked in, and it should be, you know, your recent version. And you're good to go. If you don't have backups, you haven't been using Git, that kind of thing, you got to recreate a.c from scratch. All right, so don't do this. Always make sure when you create an archive, put the archive name. All right, we are 1 minute past end of time, so I will leave it there. Exam tomorrow, 11 o'clock, 55 minutes. Try to come on time. I will be in the Zoom room if you have questions or if there's comments to make during the exam. I'll be using the chat feature then. All right, I will see you next time.